Okay. Hello, everyone.
Hello.
I'm excited to be in Japan. I love Japan. I love the food so much. I think I want to live here. I'm thinking about moving. Is the translation working? So far, so good. Okay, we'll see if we can't stump it. I'll try to use like really strange words, very nerdy words. Okay, so today I'm going to talk about building an AI application with Weave, which is Weights and Biases AI developer toolkit for building Gen AI applications. And I'm also going to talk a little bit about the future of software development. So it should be a fun talk. So my name is Chris Van Pelt. I'm one of the co-founders of Weights and Biases. I am a web developer. I love making applications on the web. Do we have any web developers in the audience today? Any folks make websites? A couple. All right. All right. Well, if you don't, you should try. It's a lot of fun. And the application I'm going to show you is building websites with AI. I also love space, hence my astronaut Gen AI photograph. One day, maybe I go to space. Okay. So I had a question. As a web developer, I thought, what if I could just ask an LLM to generate UI for me? So as a web developer, you generally have to write HTML and CSS and maybe some JavaScript. What if I just had the LLM give me a good first draft and then I make it better? It turns out modern web development often uses a framework called Tailwind CSS. Who's heard of Tailwind CSS? All right, few hands. Yes, it's a very popular framework. The idea with Tailwind CSS is that we style our web components using the class attribute of HTML tags. So by adding these classes, what Tailwind CSS is doing is actually generating these styles, and these styles are what tells a web browser how to display content. So Tailwind CSS is actually perfect for large language models because it's very compact. As you can see, py-3 means padding in the y direction is 3 EMs. That turns into like 4 lines of code in style sheet, but it's 3 or 4 characters in a class. So it's very efficient for an LLM. It means we're going to spend less money on tokens, and the LLM can be more expressive. It's inline. So as it's writing the HTML structure, it can also write the styles. So it doesn't have to pay attention to a style block over here and content over there. It's also very popular, which means the large language models were trained on it. It actually knows Tailwind CSS because it has read a whole bunch of blogs and internet stuff about Tailwind CSS. So I created this project called OpenUI. And it's an open source project. You can get to the GitHub at wb.me/openui. And I also run a demo, so you can also use this, and we'll run it in a moment. And it turns out to be a very powerful UI generation tool. And for the record, I made this before Claude released their new artifacts feature, the like UI generation toolkit. Also, the Vercel team, that is a front-end development team, they released a tool called v0.dev. It's very similar to this. But we're going to talk about some of the challenges and ultimately how I built this application in today's talk. So before I get into the details of building OpenUI, I wanted to offer a few thoughts on what the future of software development actually looks like, because just as we're using AI to translate my talk today, I used AI to build my application that used AI. It's just AI on top of AI on top of AI. So the first tool I would suggest folks check out if you haven't is called Cursor. So Cursor is very similar to VS Code. It's built on top of VS Code, but it provides supercharged AI coding functionality. So it can give you really good coding suggestions, where as I'm developing now, often I'm typing some code, I start to think, and then I look at my screen, and the AI has basically written the code I would have written, and I can just hit tab and move on. So it's definitely increased productivity. And as a developer, this was something that was surprising. I think many designers were also surprised by generative AI. We all thought, oh, our jobs, they're too special. We're going to be required for far longer. But it's actually doing a lot of the work that I, as a software developer, do. It's not replacing my job yet, but it is really powerful, and I think it's also a really good teaching tool for folks that are trying to learn new languages or frameworks. Using tools like Cursor or just GitHub Copilot and VS Code can really help you improve your coding skills. Another fun tool I was actually able to use for this project is GitHub Copilot Workspace, which is currently in beta. And this is essentially an agentic flow where we put an agent into a loop and give it tools and access to our code base. And you can kind of ask it to do some work, and it will do its best to get it done. Now, in my experience, this works 50% of the time. But when it works, it's really magical. And for this project specifically, I asked it to help me translate my interface into Korean and Japanese. And it was a perfect kind of feature or use case where it understands good frameworks and standards. And we'll see the OpenUI interface now is in both Japanese and Korean and English. Okay, so how do you even go about making LLMs work when you're building an application? I want to propose a framework of 4 key points. Number 1, it's important to experiment. And this is actually, it's so fun and so easy to do now. Everyone can make an interesting application on top of generative AI, whether it's a custom GPT in OpenAI's interface or a full-blown web application like OpenUI, which we're talking about today. Doing lots of experimentation is really exciting, and very interesting applications can be made. Now, it's important while you're experimenting to actually keep track of all the experimentation you're doing, because I know, speaking for myself, I often forget what I did this morning, let alone last week. And to be able to learn and make progress, you want to be able to have a central record of all of the experiments that you did. So next week you can go, hey, that thing I did last week worked really well for this scenario. What was that? And you can go back and see what happened. It's important to inspect individual examples. So I think a lot of AI development these days is something I would call it vibe-based development. So vibes are like how something feels, right? Like this gives me a good vibe. You can make an application and create a bunch of examples that feel good, but until you can dive in and look at the history of examples, you're not going to be able to get past just this vibe-based approach, which really isn't very scientific, or certainly is not going to convince your boss to like ship the product. And then that ties into the last point, which is really to measure progress, to be able to define a metric that you want to optimize and measure how good you're doing against that metric. This is also especially important as the space is moving very quickly, right? Just last week, Anthropic released Claude 3.5, which is now one of the strongest models in the market. But if you aren't measuring things, there's no way to know if it's actually the strongest for your specific use case, or next week when the new model comes out, you really need a rigorous scientific measuring process. So that's where Weave comes in, Weights and Biases AI Application Development Toolkit. It's comprised of 2 different components. One is traces, which is tracking everything. It allows you to keep track of all of the calls you make to, say, OpenAI or Anthropic or your own internal Llama-based endpoint. And then evaluations, which give you a rigorous way to measure how good your application is actually doing. So Weave traces are a powerful data-oriented tracing for AI apps with a single line of code. And let's go ahead and dive into a live demo, one of my favorite things to do, and hope nothing breaks. We'll see. So here's OpenUI. with my nicely translated interface. I'm not sure how good the translations are. I had some Weights and Biases employees double check it, but and I've copied a prompt that says let's build an AI SaaS landing page. We're going to create a new startup here that's going to revolutionize AI, and we want it for the Japanese market. This is currently going to Claude 3.5 Sonnet. OpenUI supports any model you can imagine, so you can try many different models in this interface. And here we can see our very professional AI SaaS landing page created with Claude 3 Sonnet. We can also go in and see the actual HTML and Tailwind CSS that was created. We could edit things here. We could change our theme because we instructed the model to use naming conventions to allow us to theme the interface. One of my favorite features of this is the ability to kind of iterate. So let's make this maybe more modern and weirder. I love giving an LLM a very vague requirement, like weird, to see what happens. It usually adds gradients. Ooh, we got some pulsing. Nice. So Weave Traces is actually integrated with this application, which means all of these experiments I just did, if I refresh this page, I'll be able to see the actual traces that were logged. So we can see that last completion is currently in progress, and this was our previous request. So first we can look at the inputs and see this is what I asked it to do, build me an AI SaaS landing page. I could see what my system prompt was. Currently my system prompt is in English, but fortunately LLMs are multilingual. And then we can also see the actual output. So there's the text that the model outputted. So this is especially useful for debugging. Here we can see a call that failed. So I could dive into this specific call and see the actual exception that happened. So as you're developing applications on top of generative AI, having a rigorous tracing tool like this can be really helpful for development. Also, once in production, by having all of this data, you can actually use it to improve your application. So you can see maybe where people are providing feedback. So we have integrations to allow your own application to actually provide feedback. For instance, here I have thumbs up or thumbs down. If a user's telling me, hey, this was bad, I probably want to look at those examples and understand why they were bad and maybe improve my prompt and continue to iterate. And this also allows you to extract all of this historical trace data and use it to, say, fine-tune a smaller model, maybe for cost savings. As we can see, these traces are actually not free, and we capture the actual usage information. So we can see how many tokens we're using and also calculate cost. All right. Moving on to Weave evaluation. So having that rigorous scientific measuring process is really key to build these applications. It's easy to make a demo, but if you aren't measuring how good the application is, it's going to be very hard for you to iterate or convince key business stakeholders that your application is ready for production. So in this specific use case, I thought, how would I evaluate OpenUI? Like if I ask it to make a website, there's kind of infinite possible good answers it could give me. There's certainly bad answers, but it's not something that I can do a simple string match on. It's more nuanced. So with OpenUI, I actually used some of the new vision capabilities of large language models, and then I used an LLM as a judge. So I have one LLM generate HTML, then I render it in a browser and take a screenshot of that HTML that was generated. Then I send that screenshot of HTML to a much more powerful LLM that has vision capabilities, and I ask it to rank that HTML on the following criteria. So how good is it when displayed on desktop versus a mobile device? How good is it in dark mode versus light mode? How relevant is it to the user's actual request? And then also, how polished is it? So how professional does it look? How good is it? And then the LLM simply ranks each of those on a scale of 1 to 4. So it can say it's terrible, it's excellent, it's poor, or it's good. So let's look at that. So actually, today before the event, I ran a couple evaluations 33 minutes ago, 40 minutes ago, and then I have a number of other evaluations historically here. And here we can see those output scores. So we have our media score, our contrast score, our relevance score, and our polish score. And then we can see actually what models we're evaluating. So the top 2 models here are Claude 3.5 Sonnet, and then a number of GPT 3.5 Turbo. And if I sort these results, which currently we're sorting by polish, I can see the most polished model is actually Claude 3.5 Sonnet with a score of 3.06 out of 4. It's still having some trouble with contrast, and most of these models are actually not great at making content that works good in dark mode and light mode. But now we actually have a rigorous process to measure how good our model is. And this is also useful to dive into the individual details. So here I can go to this specific evaluation, and I can see all of the individual examples that I evaluated. So I have a data set of different prompts, such as generate a set of badges for different status levels, or I need a grid of cards for team members, including photo, name, role, and a short bio. And these are the actual scores that the LLM as a judge gave. So it scored some of these low on contrast, high on polish. So here we can actually see the generated HTML. So you can see this one was docked on contrast because in dark mode I can't even see the badges. Or we can say, hey, show me the most polished examples here. And we can see what those look like. So here's a newsletter update or a login page. Again, on this login page, we can capture all of these nuances of is it good in dark mode and light mode, and continue to iterate and improve on our core application. All of this data is exportable, and as mentioned, we can then potentially use this data to fine-tune or further iterate on our AI applications. Okay, that's all I have for you guys today. You can learn more about the Weights and Biases Weave offering at wndb.me/weave. And I'd be happy to take any questions if folks have them. Thank you so much for having me.